Well, good evening, everyone. Welcome to Dome at Home. Happy Thanksgiving to our American viewers out there. I hope you enjoyed a nice day of turkey or whatever it is that you do for Thanksgiving. I guess not everybody does turkey, but regardless, happy Thanksgiving. Of course, up here in Canada, we had ours last month, and we're now in the depths of winter, at least here in Winnipeg. I'm Scott Young, your host and planetarium astronomer at the Manitoba Museum. It is good to see you all. I see lots of people checking in through our chat. We're live on Facebook and YouTube. And whichever one you're watching on, if you contribute to the chat there, it gets sent over to the other one as well. So we're all one big happy family here. So that way everybody can see what everybody's saying and so on. Great to see you all. It is, I just saw James's comment go by. It was nice and clear all day. And I just went outside before the show to see if I could see the space station go over. And it's clouded over now. So it's kind of been it's been a tough time looking at the sky. There has been, this is that time of the year where if it's clear, that means it's going to be really cold. And if it's warm, that means the clouds have rolled in and it's keeping the heat here on the Earth. So it's kind of a tough time. We are into the depths of the long, dark night, though. And so you can get some nice early observing done. We're going to be taking a look at, a few different things, actually. Our feature tonight is 50 years of dropping stuff on Mars. 50 years ago this week, the first human spacecraft from Earth landed on the red planet. And we're going to talk about that. And, we haven't spent too much time on Mars for the last few weeks, so I thought we'd go back there and touch base with all the probes that are going on there. We're also going to be taking a look at a binocular challenge, an object that you can track down with your binoculars, a dwarf planet actually, and we'll be looking at all the things that are up in the sky. As always, we love to know where you're watching from and how many of you are watching. That helps us with our statistics, so please say hi in the chat there. It's great to see all of our regulars checking in. A few new names as well. That's great. And happy Thanksgiving, Anthony from Pennsylvania. Thanks for stopping in. I wasn't sure if our American friends would make it to the show live today, because I know when we had our Thanksgiving dinner, I had a turkey coma for about 2 days. So, all right, let's get started. We're going to head outside to the simulated sky and take a look at, what's up there. I was driving home from an appointment about 5:30, and the sun had set. The sky was still fairly bright. Actually, I guess it was about 5. The sky was still fairly bright, but you could already see Venus, nice and high that early. But by 6 o'clock, it was already down in the trees, and you lose sight of it about 6:30 or so. So Venus is still up there. It's still over in the southwest after sunset, and it's drawing a lot closer to the other planets. We've been looking at Saturn over here and Jupiter. Those two have been close together for the months already, but they were way over on the other side of the sky, and now the orbits of the planets are sort of bringing them all together, and we've got this nice line of 3 planets in the evening sky. And those will just be getting closer together over the next months or so. That's really the highlight of the southern sky. If we go back over to our western sky, and here we'll zoom out just a little bit, we still have that ridiculous summer triangle hanging around. Here it is, end of November. We've still got the summer triangle visible and pretty high in the sky too. The Milky Way still goes right through that, and actually, in the early evening, if you get a chance to be outside of the city when the moon is down in the early evening, the angles are such that the Milky Way sort of sticks out almost perfectly vertically from the horizon. It goes right through the center of the summer triangle here. And so if you're a photographer, this is a good time to get out there in the early evening and take your Milky Way shots. Going around again to the north, our Big Dipper is nice and low in the sky. The 2 pointer stars, the 2 stars in the bowl farthest away from the handle, they point up to the North Star. And there's our North Star directly in the north with the very faint Little Dipper. You might not even be able to see it. I certainly can't see it from inside the city with all of the lights. But usually I can see these 2 at the end here. But the rest of it in the middle there, it's just a little bit too faint. Moving over to the east, this is where the new stuff is always happening. This is where the new constellations are rising. We've got that bright star Capella in the northeast. And we've got, here we'll zoom in a little bit more here. Let's just bring this back. We've got star clusters rising. We've got the Pleiades star cluster that we talked about a few weeks back, or the Seven Sisters. We've got the Hyades star cluster, which is a V-shaped group of stars that marks Taurus the Bull. And if we draw on our lines here, these stars here all make up Taurus the Bull. But for me, it's really the V shape, and then these couple that sort of go up here. I can at least sort of think of those as the bull's horns. Here, we'll just bring that up a little bit higher. So you sort of have this V shape of the bull's face, and then there's a horn over there, there's a horn over here, and that connects to another constellation, which is Auriga the Charioteer, which is sort of a pentagon of stars that we can see fairly easily. The winter stars start rising by about, if you get out around 9 o'clock, our friend Orion the Hunter is up. Orion is one of those winter constellations that is just almost iconic. It's one that most people have heard of, particularly because of the belt of 3 stars. Orion's belt featured in the Men in Black movie. It features in many memes. The belt didn't fit very well, so you get a 3-star review, that kind of thing. Orion really does, for me, epitomize winter, though. When I can see Orion, first of all, I'm usually cold, but it sort of evokes, maybe it's because it actually looks like a person. It does feel like it is a person up there in the sky. It's like you're greeting an old friend when you see Orion in the sky for the first time of the season. And like I say, right around 9 o'clock, it's already starting to clear the trees. And we'll spend some time with Orion in a later show, because there's so much going on in that constellation, especially if you've got a pair of binoculars or a small telescope. That we'll feature Orion a little bit later in the season, I think. Okay, Tiffany's saying, yeah, Orion really does take over the sky. Absolutely. I mean, the stars are so bright, you won't find 3 stars as bright as the belt of Orion that close together anywhere else in the sky. It is literally unique. And you can use Orion actually to point towards all sorts of other constellations. It's kind of like the winter Big Dipper. With the pointer stars that point to the North Star. Orion, you can draw up from the belt of Orion. You can draw down. You can go from this corner to this corner to this corner, and draw all sorts of lines that will actually lead you to pretty much all of the major winter constellations. Okay, let us just move on. I just want to get back over to the southwest here. We were taking a look at Jupiter over the last couple of weeks. Jupiter is actually now getting low enough that unless you catch it really, really early, it's going to be pretty much done for telescopic viewing. When things get close to the horizon here, we're looking through all of the ripples in the air and the heat waves and the heat coming off of the ground and off of people's houses and things like that. And all of that heat with the moving air, it distorts the view. So when planets get down low to the ground, you don't get a good view of them with telescopes. So we're almost done with Jupiter. I am going to try and get another couple of nights this week, and maybe into next week. We'll see what the weather is like. But with the combination of cold and them getting down so low, that'll probably put an end to our planetary observing for this year until things swing around to the other side. And then we'll be able to get up in the morning. All right, let us do our some updates here. We've got planetarium shows that are opening up for December. We've got our sort of special holiday shows. The Alien Who Stole Christmas. If you haven't seen that and you're at all a kid, even a kid at heart, it's a hilarious show. It's basically the night before Christmas, except in the first stanza of the poem, Santa gets abducted by an alien who takes him on a tour of the solar system. It's actually really cute. Great if you've got younger kids. And then the other show that we run is called Season of Light. And it's basically, if you look at all of the holidays that happen at this time of the year in the Northern Hemisphere, because it's winter, it's long nights, there's always festivals to do with light. Christmas, Hanukkah, many other groups, Diwali, all of these things that happen around this time of the year have to do with light. And that's because we're in this dark time. So we go into some of the traditions from around the world. There's quite a an emphasis on Christmas, but also many other places from around the world and throughout history, which is kind of fun. And so that's a great show. Got some really nice music, and it's probably not for really little kids, but it's a great show for everybody else. And then, of course, there's also the regular classic planetarium show, the Manitoba Skies. So you can always check that. Images. We've been getting more and more people starting to send us some pictures, and we're going to add this as a regular feature. So if you take pictures of stuff, even if you think it isn't great, I mean, this is the best eclipse picture from Manitoba that I've really seen, because Ulrich got out there and went out even though it was cloudy and got some pictures. I checked at midnight, checked at 1 a.m, checked at like 2:30 or so, and then I just went to bed and I slept through it and I missed it. So, I mean, it's the dedication to get out there. So well done, Ulrich. Thanks for letting us share your picture as well. You can see the shadow of the moon across there, and even though it's through clouds, it kind of gives it a really ethereal kind of look. So I really like this picture. If you'd like to see your picture shown on the show, send it in. You can always send it to us through social media or space@manitobamuseum.ca. That'll get to me as well. Okay, we're going to do a little thing for binoculars here. If you don't have a pair of binoculars, it's okay. The tactics that we talk about here also apply to tracking down things in the sky, whether you're using your naked eye, whether you're using binoculars, whether you're using a big telescope. The same kind of principles apply. So hopefully you'll find it interesting. If you go out and look towards the east, we have the constellation of Taurus, the Bull, the Hyades star cluster right here, the V shape that we talked about. There's the Pleiades up here. Let's see. The Hyades is about the size of a field of view of binoculars. If you take a regular pair of binoculars, you can pretty much fit that whole area of the sky in them. It turns out that very near that easy to find star cluster, it is, well, it used to be called an asteroid. Now we call it a dwarf planet. It is the dwarf planet Ceres, and it is now at its closest, well, brightest point, pretty much. And because of the combination of brightness and the fact that it's near some useful milestones, it's pretty easy to find if you have binoculars. So we're going to take a little zoom in here. So we're going to just zoom in right around the Hyades there, and we get this look here. So here's our Hyades, this sort of V-shaped group. In binoculars, there's way more stars, probably, I don't know, 50 or so stars that you can see in binoculars. Ceres is this tiny little dot over here, and this is the view tonight. So if you go out right after the show, basically you can look from the point here and just sort of look up a little bit, and that's where Ceres is. Now, it's not going to jump out at you. You're not even going to be able to tell the difference between Ceres and one of these other background stars here. The only way to really tell the difference is to basically make a little sketch of what you can see. Or this chart is available on the museum's website. I'll drop the link in the chat in just a minute. You can print it out, and then you can basically, check off the stars. Yeah, I see that one, I see that one, I see that one, and then try and figure out where Ceres is, and then go back the next clear night, because all the other stars will be in the same spot. But by tomorrow night, Ceres will have moved just a little bit. But each night it moves a little bit because, of course, it's orbiting around the sun. This is what asteroids, or in this case a dwarf planet, looks like. They're so small that they just look like stars, and they only betray their existence by their motion. And so this is a perfect time to track down a dwarf planet in binoculars. It will be one of the fainter stars that you can see in your binoculars, but it should be something that you can track down over the next number of days. Basically, and from now through December, it'll be bright enough to see, but each night as you see it moves farther and farther away from that star cluster, and so you start to lose your landmarks. Just for a sense of scale, the circle here is about the field of view of a regular pair of 7x50 binoculars. If you got the higher power ones that we were talking about earlier in the year, the 15x70s or whatever from Canadian Tire that we all picked up on sale, that's a smaller field of view. So you just have to be aware of what you're looking at. Take a look at this at the Hyades star cluster first and compare that to the map, and then start to figure out, okay, well, here are these two stars. I can see them. I'll move off to the right. Can I see these other ones, and so on? It takes some practice. This is called star hopping, and it is the way that you point telescopes. It is the way that you find things in the sky. Even if you have a computer-controlled telescope, to make sure you're actually pointed at what the computer says you're pointed at, you need to learn how to star hop. So this is a very, very useful skill, and you don't need to have a telescope to do it. Just a simple pair of binoculars will build up that skill for you, tracking down, in this case, the dwarf planet Ceres. So the let me just put our link into the chat so that you can all grab that chart. If you like doing this kind of stuff, we're going to try and do more binocular stuff. I know that there's a number of people out there that are doing binocular viewing and so on. So it would be, it's always great to see some of the stuff that people are doing. Send us your pictures, send us your images and things like that. We'd love to share those. Okay. So that's how you track down the dwarf planet Ceres. We're going to go on to our featured theme here. I'm just going to go back here to see if there are any... let's see. Oh, hi, Melissa. I just saw your question here. Your moderator, Rowan. Hi, Rowan. Nice to see you too. But you're wondering about Cassiopeia. Yes, Cassiopeia is a constellation that... Actually, why don't we just go back to our sky here for just a second? Cassiopeia is actually almost right overhead at this time of the year. So that's kind of why I forgot to show it, actually, is that I looked in north, south, east, and west, but I didn't look straight up. Cassiopeia is almost straight overhead, and you've got this W-shaped group of stars that is supposedly the queen sitting on her throne. It stays really, really high up most of the night until midnight or so. It's sort of moving across from the northeast high up overhead and then slightly down into the northwest, but always very, very high at this time of the year. So that's where you can catch that. And yeah, sorry, I forgot one of the 5 cardinal directions. Did we have any other questions here? Oh, lots of folks checking in from Winnipeg. Lots of folks saying hello. It's great. Okay, so let us move on to Mars. 50 years ago this week, an alien spacecraft headed towards a distant planet, and this is the view that it had on the way in. The planet is red. It's got a little ice cap at the top there. The planet is Mars, of course, and the spacecraft was from the Earth, but it did actually look like a flying saucer. This is what the spacecraft looked like, this sort of saucer-shaped thing with some things sticking out in the top. This plummeted into the atmosphere of Mars. The heat shield at the bottom prevented it from burning up and then dropped away. And inside was basically a cannonball with little petals that were supposed to open after it landed. And so this had some parachutes and some scientific instruments and some radios. And this was going to be the first landing on the surface of Mars. The probe was called Mars 2, and it was sent by the Soviet Union 50 years ago. And it was an exceptionally sophisticated mission. I mean, we would be proud to be launching this mission today. It had an orbiter that would stay in orbit and take pictures and relay radio back from the lander. It had the lander, which would had a little arm that went out and would sample the surface, and just revealed a few years ago after some of the stuff was declassified, it also had a little rover on it. Not a wheeled rover, but it had these little sort of skis that would sort of pull it forward as they rotated around. 50 years ago, we were putting little moving vehicles around on Mars. Now, unfortunately, Mars 2 did not have a very good mission. The parachute never opened. And so it went in like a cannonball, and it hit the ground like a cannonball, and probably left a very small crater, and that was the end of that. However, Mars 3, which was on the way at the same time, actually worked better. The orbiter went into orbit, the lander went down. The sort of flying saucer part survived the atmosphere. The cannonball came out. The parachute opened. It parachuted down to the ground. It landed safely, deployed all of its antenna and things like that, and began to transmit the first picture from the surface of Mars 50 years ago. And this is that picture. And 14 and a half seconds into the transmission, it went dead. So scientists have analyzed this. People have looked at this image over and over again. Is it an actual picture? I mean, is that the horizon of Mars and it's just like really out of focus or something? No, it's just static. This is all electronic noise. There was no image transmitted. It started to work, but then for some reason went offline. Now, something that was going on at the time, Mars was under a global dust storm. The entire planet was basically a giant sandstorm. So as these spacecraft were going in, they were being buffeted by 100-kilometer-an-hour winds with sand, sandblasting them and so on. There's all sorts of static electricity that builds up on the spacecraft. There could have been a short. There could have been all sorts of different issues. That dust storm started after the spacecraft were launched, and there was no way to change any of their programming or delay their landing or things like that. It was pretty much automatic. So unfortunately, those first spacecraft really didn't do all that much from the surface. The orbiters, on the other hand, did quite well. There were some great pictures of Mars taken from the Mars orbiters from the Soviet Union, and also Mariner 9, which was the American probe, had actually arrived about a week earlier and had stayed in orbit. It didn't have a lander, but it was in orbit taking pictures and things like that. So the exploration of Mars had really gotten underway. So it was I just saw a comment, Michelle. Hi, Michelle. Talking about the image of static. Yes, but it was 18 hours of static. Yeah, just like in the Contact movie with the Carl Sagan book. Alas, no, it was literally one frame like this. But we would have loved to see stuff from Mars that early, but we wouldn't have to wait very long. This is imagery from Mars 5, which went a few years later, and since then we've been throwing stuff at Mars pretty much every couple of years. Every 26 months, the planets sort of, as they go around the sun, the two of them line up so that you're kind of at the minimum distance that you can send a rocket there fairly economically, and it doesn't take forever to get there. So every 26 months, pretty much, there have been opportunities to launch. And on a lot of them, spacecraft from Earth have gone there. A lot of them have failed, particularly the early ones. In fact, the Soviet Union and now Russia never successfully landed a spacecraft on Mars, other than Mars 3, which survived for 14 and a half seconds. So they don't have a great record for that, unfortunately. The Americans have just as many failures, but they launched more probes, so they also have some successes. And so beginning with Mariner 9, the orbiter that was taking all the pictures of Mars, looking at those sort of black and white pictures, the first half of its mission was basically a waste because all it was doing was taking pictures of dust because the whole planet was covered with a dust storm. So from orbit, you couldn't see anything. It's like it was cloudy everywhere. But eventually the clouds cleared. Mariner 9 sent back some decent images of the craters of Mars and the various surface features. In the 70s, the Viking spacecraft went there. And Viking had an orbiter as well, and they had a lander. And they learned that maybe just having a cannonball with a parachute wasn't the best way to try and land on Mars. The Viking landers had rockets, and they had ways to steer and ways to avoid rocks and things like that. And so Viking eventually made it to the surface of Mars in 1975 and started sending back these kinds of pictures. And there actually, if you watch the Carl Sagan Cosmos series, one of the episodes, my second favorite episode, is called Blues for a Red Planet. And it's all about the Viking missions to Mars and the scientists that were working on what was really the ultimate experiment, trying to detect if there was life, in the soil of Mars. So that was something that was really, really a big question. The results were kind of inconclusive. At first they thought, yes, there's life. Then they realized, oh, wait, no, maybe not. And there's still the experiment helped us design better experiments to look for life, but wasn't conclusive on its own. So more probes had to be sent. And over the years, we've sent everything from a rover that's the size of a remote control car, all the way up to, here's the European Beagle spacecraft. It was supposed to land, and in fact it did land, and it had this complicated design with all these fold-out solar panels, and then underneath all the solar panels, that's where the radio antenna was, and one of the panels didn't open, so the radio could never deploy and talk to anybody. So it landed safely. One little thing jammed, and the whole thing was basically a write-off. We took pictures of it from orbit from another spacecraft, but we never heard from Beagle, unfortunately. And throughout the times, we've gotten better. The more recent spacecraft have survived with a much better rate, but even still, there have been a few spacecraft in the last 10, 15 years that have just disappeared without a trace, essentially. Or not without a trace. We know where they went. It's just something went wrong and they weren't able to fulfill their mission. I think one of my favorite spacecraft to Mars in the last little while was this one right here. This is the Phoenix Mars lander. It landed up in the near the polar regions of Mars, in the area that is under the ice in the winter. And it landed in the summer. And one of the cool things was that on it was a Canadian-built weather station. And so we had this weather station on Mars that was sending back daily weather reports. And I remember it was in, I think, 2008. We were in a meeting at the planetarium talking, and it was winter, like it is now, but it was summer on Mars where the Phoenix probe was, and it turned out that it was colder here in Winnipeg on that day than it was on the planet Mars. And I said something at the table, and the social media person heard it and came over, and then my boss came over, and suddenly we had a meme going that Winnipeg was colder than Mars, and that still comes back every single winter. That will probably be my claim to fame, being part of the Winnipeg is colder than Mars originators. So kind of cool to see. Yeah, no one does winter better than Canadians. That's certainly true. Let's see. Oh, lots of comments here. Let's see. Ulrich was asking, how did we know about the sandstorms on Mars at the time? We actually mostly knew from the spacecraft, but also from telescopes. When you look at Mars through a telescope, you can see the dark markings on the surface. But when there's a dust storm, all of that sort of gets blocked off, and the whole planet just turns a single color of orange. And so we knew sort of what was going on, but we were powerless to make any changes. These early spacecraft, they're kind of like an old alarm clock, like a wind-up clock. That's the level of automation they had. There was no sort of radioing in and changing the programming on the fly or anything like that. So they were kind of stuck. Let's see. We have... Melissa was talking about the space junk around Mars. Yeah, there's already a bunch of orbiters like Mars 2, Mars 3, some of the other ones as well, that are inactive, like they're burned out basically. So they're still in orbit. So it's kind of sad that we are already polluting the orbital space of a second planet as well. Although I do have to say, eight spacecraft around a planet versus 200,000 or so around Earth. We've got a ways to go before it's too bad. but yeah, you're right, it's already some stuff there. Sometimes you see in science fiction movies where they show like 1,000 years from now or something like that, and then you fly by the moon and there's the Apollo 11 space capsule, and it's like roped off like a museum, and there's a little plaque there and things like that. I've always sort of thought it would be cool to go and pick up some of these spacecraft one day. I mean, eventually we're going to get to the point where we can clean up debris in Earth orbit. We're going to have to. Let's take that to Mars when people go there. Maybe we can grab Mars 2 and bring it down and put it in a museum. That would be really, really cool. Let's see. Michelle was saying, Cheryl was saying, Yeah, most humans can't stay on paved roads without considerable help, so the scientists getting a vehicle through space is pretty impressive. Valid point. Granted, there's a lot of scientists working together, so when one of them does something stupid, usually another one can catch it. If we all had that kind of backup, we'd probably do better down here on Earth as well. Yeah, that was. And then the Mars meme. Yeah, I will admit I just provided the information that started it. Really, it was my colleague Holly Moncrief, who was our social media person, and then my boss Javier Schwersensky was like, "Oh, we got to put this out," and it became one of our biggest social media posts ever. So that was fun. And then Jennifer is Portage and Main 50 Below. Yeah, a classic song, and I mean, the weather on Mars goes up to about 0 degrees, which seems quite comfortable, right? Well, it turns out it's not really comfortable. That's only at foot level. The air on Mars is so thin that probably at your head, 5 feet or so higher, the temperature is probably 15 degrees colder. Actually, I'm not sure of the number, but it is colder because the air is thinner. And most of the time, it's quite a bit colder than that. I mean, it goes down to minus 70, minus 80, minus 100 at some points. So we were kind of cherry picking data. It just happened to be, it's like you can always find, one day you'll see the weather and Churchill is warmer than Winnipeg that particular day. That doesn't mean it's true all the time. But anyway. Okay, some of these other Mars rovers, we've talked about the exploration rovers, Spirit and Opportunity, the Mars Science Laboratory, Curiosity, which was an amazing spacecraft. As Michelle said, it came in like a boss. It came in straight, and it had its own rockets and lowered itself down to the ground. It was a fantastic mission. That's still up there, of course. Perseverance is working away. And let's see. There we go. There's Perseverance and Ingenuity. Ingenuity just had her 16th flight, which is pretty amazing. It was only supposed to work once for 30 seconds. So we're getting our money's worth on that particular helicopter drone on Mars. It's getting all sorts of great pictures. And more importantly, I think, the engineers are learning about how to use this kind of technology to sort of leapfrog ahead of the rover and pick out interesting sites for the rover to then drive up to and drill into the rocks and take samples and things like that. It's a really, really efficient way rather than having to get satellite imagery, which is, from much, much higher. It's not as high detailed, whereas the drone can basically fly right over the rock you want to look at. So it's pretty cool. All right. I would be remiss if I didn't talk about some of the other successful Mars missions. We got China's Tianwen-1 landed, and this was another one of those missions that was really impressive. It had an orbiter, it had a lander, and it had a rover. All 3 possibilities, essentially. The only thing it didn't have is some kind of flying vehicle, but apparently it will be that will be part of the next Mars mission. And it was functional for a few months there. So that was. I still don't know the current status, to be quite honest. There's still not a lot of pictures that have been released. I've seen a few images, and there's some scientific data and so on, but not nearly as many that are easily available. So 50 years we've been pelting poor Mars with stuff, from cannonballs to SUV-sized remote control rovers and little helicopters. We've learned a lot about Mars. We still haven't answered that question that the Viking mission was looking at in 1975. Is there life there? It's a difficult question. There's certainly not as much life there as there is on Earth. If you landed on Earth and you did any kind of experiment to detect life, you would find it, because life is everywhere. It's in the ice, it's in volcanoes, it's on the tops of mountains, it's in the upper atmosphere, it's underground, it's everywhere. Mars isn't like that. Maybe it's underground, maybe there are places we haven't looked, maybe there are ways we haven't looked yet, but that's what the next set of rovers and spacecraft will be working on. And I'm pretty sure we'll be sending stuff to Mars until we know the answer to that. That's one of the questions that we've wanted to know since forever. Reese is asking, how hard is it to see the moons of Mars from Earth? Well, you can't. The moons of Mars are actually these tiny little asteroids. They're like little potatoes. They're, I think, 8 kilometers across and 16 kilometers across, whereas our moon is 3,400 kilometers across. So these things are so tiny, they're hard to see even from the surface of Mars. And I think they can be detected in like giant telescopes, but certainly from your backyard, you wouldn't be able to see them even if you had a pretty big telescope. We're talking like observatory level gear that you would need. Let's see. Okay, how are we for time? Oh, geez, I've been talking a lot. It's time for...
Cool Space Stuff!
All right. There are a couple of big launches that happened this week. First of all is the DART mission, the Double Asteroid Redirect Test. Asteroids crash into things. That's a problem. 66 million years ago, an asteroid crashed into the Earth, and that finished off the dinosaurs. That is a difficult thing to deal with because asteroids are big and they're moving very fast. However, if we knew about one that was on a collision course early enough, we could maybe get out there and nudge it just a little bit. And even though it moves just a little bit, over the long distance, that turns out to be enough to miss our planet. So we've launched this spacecraft. Now, you don't want to mess around with asteroids, so we haven't launched it at an asteroid that actually is a threat to Earth. You don't want to accidentally bump it into Earth while you're doing a test. So the asteroid is actually a double asteroid called Didymos and Dimorphos. The moon Dimorphos orbits around the bigger asteroid. And so the DART mission is going to go out and it's basically going to crash into the moon at high speed. The moon is about 0.5 kilometer across. The main thing is about 1 kilometer across. The moon is about 50 meters across. So it's bigger than the spacecraft, but it's not so big that we can't move it at all. So the spacecraft's going to crash into the moon, and you can basically see the effect of that impact by watching the way that the moon goes around the larger asteroid. So normally these two things are going around each other. You can actually measure that with a telescope, know how long that it takes to go around. Then the spacecraft will crash in and it will slow down the moon a tiny little bit. We think it'll change the orbital period by about a minute, but that's enough to measure. So this mission will help us understand what it takes to move an asteroid. I mean, it'll give us basically one data point on the graph. Cheryl's saying, yeah, I've seen how this movie ends. Yeah, exactly. It usually involves Bruce Willis, I find. But one day we're going to have to do this. Maybe 10,000 years from now. Maybe next week. We really don't know. There are asteroids out there. The odds of anything hitting us is really, really low, but it's not zero. And I mean, if you live in Tornado Alley, you have a tornado shelter. The odds of a tornado hitting you, really, really low, but you still have a shelter just in case. Well, if an asteroid hits the Earth, it's like we all need a tornado shelter. It's better if you could divert the tornado instead, and that's what this mission is about. So hopefully this works. This is cool. Tomorrow night, the Solar Orbiter, which is a spacecraft that's going out to study the sun, has been doing this complicated loop around a bunch of planets to get to its proper orbit. It zooms past the Earth tomorrow night. And it comes so close that it becomes visible probably in a good pair of binoculars, certainly in a telescope, if you know exactly where to look. I'm printing out charts and things for it now. So tomorrow about 10:40, I think the time is when it becomes visible for us here in Manitoba. And we'll get to see it as it moves across the entire sky in about an hour. So it's pretty fast moving. The Heavens Above website has all the details that you need for that. It'll print out star charts for you and tell you exactly where you need to look. Now, this is probably not the kind of thing that you can just pop outside and look at. This is the kind of thing that you probably need to be a fairly experienced observer to find, because just like looking at Ceres, it's just going to look like a dot, but if you look 5 minutes later, it will have moved. And so it'll be interesting. I'm going to try and do it with the video camera, and if I get it working, I'll start streaming the images. But that's something that's coming up. This has become more complicated with last week's anti-satellite missile test by the Russians, because this spacecraft actually comes close enough to the Earth that it goes through the geocentric satellite band, and it goes through low Earth orbit. So it actually goes through the same altitude that all of that debris is now floating around in. There's no way to stop it. There's no way to do much in the way of maneuvers. I mean, they do have one potential maneuver planned for early in the day tomorrow, but you're flying through a cloud of material and just hoping you don't get hurt. So that'll be interesting to see what's going on. Ulrich was saying, how fast will we see it moving? You should actually, in your, say, 15 by 70 binoculars, you should be able to see it actually moving in real time. It will look like a little star moving along, right at the limit of sort of how fast right at the limit of what your eye would notice, essentially. So you'll look at it, and 5 seconds later, you'll look at it again, and it will have moved noticeably. I'll put some more stuff out on my Scott the Skywatcher page to if anybody wants to take a look at that, because it's one of those, not quite once in a lifetime, but certainly a fairly rare kind of opportunity. So I like to bring those out where we can. Let's see, there's some other stuff. New Russian module going up for the International Space Station launched yesterday. It's basically a docking port with a bunch of docking ports attached to it. So this allows a whole bunch of different spacecraft to attach to the Russian module, rather than just sort of one in that particular spot. So that'll be interesting. Given the issues that the last Russian docking had, that the whole thing sort of started spinning uncontrollably and engines firing randomly and stuff like that, it'll be interesting to watch this. Docking is set for tomorrow, so I'll be watching that on NASA TV for sure. And it's going to basically dock right at the bottom of the Nauka module that we talked about a couple of months ago, and allow a bunch of spacecraft to dock in there. This is a sad story. The James Webb Space Telescope, as they were unpacking it at its launch site in French Guiana, I don't know exactly what happened, but if you've ever had to move a heavy box and you've got like 4 or 5 people all carrying this box, and one person has to like scratch their nose or something, and it just so happens that somebody else is scratching their nose at the same time, and suddenly the whole thing just goes. That's what happened with the James Webb Space Telescope. The whole thing, a clamp released uncontrollably, and the spacecraft stack sustained vibration, as they put it in the official report. So basically, somebody dropped something. It doesn't seem to be damaged, but they've delayed the launch by 4 days to be able to go through and check absolutely everything. Because unlike the Hubble Space Telescope, the James Webb Space Telescope will be 1 million kilometers away from Earth, and there's no possibility of servicing it. So if something goes wrong, it's done. Whereas with Hubble, they could go up with the space shuttle and pull out broken pieces and put in new things and do all sorts of stuff. Not so with Webb. This is a one and done kind of launch, and so everything needs to be perfect. So the launch is scheduled December 22nd. We'll be covering that live. It's an early morning event, and as the times change, we'll be updating our events for that as well. Okay, we'll end off with a bit of good news. Comets. Comets are wonderful objects when they're big and bright and beautiful. Most of the rest of the time, they're extremely boring. You can't even see them. But you can never tell what a comet's going to do. Well, there's a comet out there that you might have already seen some stuff on, Comet Leonard. They're calling it the Christmas Comet because it's not going to be very well visible during Christmas time. But apparently, if you call it the Christmas Comet, you absolutely get lots of clicks on your website. So it's been called the Christmas Comet. Hey, Kevin! Wow! Sorry, I was just distracted. A friend of mine from all the way out in Ontario. That's fantastic. I'll get back to you in a second, Kev. So yeah, this comet is going to be bright, but not at Christmas time. It's actually going to be at its best next week for us here in Manitoba. Right now, if it's in the morning sky, and you can see here, here's our Big Dipper. And if you remember finding your constellations, the arc of the Big Dipper's handle, you follow the arc to Arcturus. That's the bright star Arcturus, which is just rising in the east around 3 in the morning, our time. And this comet is parked sort of making a right triangle with the end of the Big Dipper and Arcturus. That's where it is tonight. It's only bright enough to see in good-sized binoculars from a dark sky right now. But over the next 2 weeks, it's going to be moving this direction down towards Arcturus, and it's going to be getting closer and closer to the Earth, so it'll be getting brighter and brighter. How bright? Maybe bright enough to see it barely as a little fuzzy patch with your unaided eye, in which case it'll look great in binoculars and fantastic in a telescope. If the predictions are off one way, it won't be visible at all and it'll be a bust. If the predictions are off the other way, it'll be very bright. So we're going to be watching this very carefully. Bright comets are quite rare, and when there's a bright comet, that's the time to pretty much change all your plans, drop everything, and take advantage of whatever clear nights you have. Because given the weather and things like that, you may have 2 or 3 nights to see the comet before it's gone. So keep plugged in with that, and we'll update you as much as possible as soon as we start to see which way the predictions are going for this comet. But don't think that you can wait till Christmas to see it, because by the time it's Christmas, it's actually past its prime. It's moved over into the evening sky, and it's down pretty low in the sky. So our best chance is going to be the next 2 weeks. So keep your eyes open. So that's we've got one more bit of cool space stuff that I really should have talked about earlier. So my friend Kim Hay from Ontario, dear friend of mine, and Kevin as well, are wonderful people. I've been doing astronomy with them for 400 years or something like that. Kim was secretary of the Royal Astronomical Society of Canada, and has been active in all sorts of outreach and stuff like that. Just a really wonderful person. They just named an asteroid after her. So asteroid that used to have the great name of number 10062 is now named asteroid Kim Hay 10062. So that's pretty cool. Asteroids get named after people. And there are a few folks a few Canadian astronomers that have gone out of their way to find amateur astronomers that make contributions to outreach or to research or to whatever, and name asteroids after them. So that is a great thing. And I made her blush again. Yes, good. Yeah, that's really exciting. Well, welcome to the club, Kim. It's a very strange club to be in, but it's one of those things that. There's, for better or for worse, you're going to be immortalized on that piece of rock going around the sun. You just hope that isn't the one that we're going to have to redirect with a spacecraft and send Bruce Willis to, right? That's not the kind of fame anybody wants. So it's really good to hear from you guys. And that's what I love about this show. We get people from all across Canada down into the States. We've got people around the world. And we just all like the sky. And that's what brings people together. So thank you all for joining me again. I'll put up the links here so that everybody remembers how to get a hold of us. We do love to get mail. Please send in images or drawings. I remember back when we started the show, we had some stuff from my friend Lander, who was doing some observing and then made the Mars lander and stuff like that. And Rowan has sent me some things as well. There's a bunch of folks that have sent us stuff in. Please do. because I love to see what people are doing. It really inspires me to, bundle up and get out there in the cold and go do some observing. And I think I'm going to go check the sky now just to see if it has cleared. I think I will go out. It's been great to spend all this time with you. So thanks, everyone. Have a wonderful evening. And I've just got to make sure that we get our. Sorry, I have to put in the credits, which is legally required. So we can have that there. Next week, we're talking about the solar eclipse. Eclipses always happen in pairs. Last week we had a lunar eclipse. Next week we have a solar eclipse. Well, not we. If you are in Antarctica, you'll have a solar eclipse. The rest of us, not so much. But we are going to talk about eclipses, and we're going to be hopefully updating you on how wonderful Comet Leonard is going to be. So that'll be next week, 7 o'clock Central, here on YouTube and Facebook. That's Dome at Home for this week. So on behalf of everybody at the Planetarium, thanks a lot, and we'll see you all next week.